Hello everyone, I'll welcome you for our next video session. In the last class I have mentioned we have two different tests to check the uniformity of the random number. One is KS test, that is Kolmogorov-Smirnov test, that already we have seen. Today I am just going with one more test, that is called as chi-square test. Okay, here also we have a procedure in order to just do this problem. Let me just come with the step 1. This is the procedure. First you have to divide the data into different class intervals of equal width. Okay, for example in the question they will specify you have to divide for 0.1, 0.2 or 0.25 interval like that. You have to just see that one and then you have to just divide the data into different class intervals of each width. Okay, it should be of equal width. Then step 2, find out how many random numbers lie in each interval and hence find OI. Here we call OI as the observed frequency and then EI as the expected frequency. Okay, we have to find out this OEI using the formula n divided by n. N means it is total number of observations and small n is total number of class intervals. You know what is this class intervals. When you come to the problem, I'll just show you how you have to find out the random numbers. Means how you have to count the random numbers, that is OI. Okay, for EI we have a standard formula n and then capital N divided by small n. And the third step is you have to calculate x0 square. This is the chi-square function. X0 square. How you have to find out this one? Already we know OI and EI in the previous step. So in this third step you have to find out x0 square. That is summation I is equals to 1 to n. 1 to n means this is the intervals, the number of intervals, class intervals you have. OI minus EI whole square divided by EI. Then step 4, what you have to do, you have to obtain the critical value as we have seen in the last problem, d alpha. Here we are using the term x, that is chi-square function. Thereby we are using Kolmogorov-Smirnov function, that is d. But here we are using x square alpha comma n minus 1 from chi-square table. As we have seen a case table, in the same way we have a chi-square table. From that you have to find out the critical value. Then as usual you have to just check whether x0 is greater than this x alpha or it is less than x alpha. If it is greater, then you have to reject the hypothesis. If it is less than or equal, then you have to accept the hypothesis. And then you have to say the numbers are uniformly distributed. Okay, and here we are using alpha comma n minus 1. Previously we were using only alpha, but here we are using n minus 1. What is this n minus 1? This is the degree of freedom. Okay, n minus 1 is the degree of freedom what we are using. Now let me come for the problem. See, use the chi-square test with alpha is equals to 0.05 and to test whether the data are uniformly distributed. Okay, the test uses n is equals to 10 intervals. Okay, there are 10 intervals of equal length 0, 0.1, 0.1 to 0.2 till 0.9 to 1.0. These are the equal intervals starting from 1 to 10. Okay, because n is equals to 10 intervals they have given and they have given the interval also. Now we'll go for the solution for this. See here, this is the given value, time intervals, the intervals they have already given. Okay, see here you can count 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 10 you have, this is the number of intervals, that is small n, that is n is equals to 10. It is given in question. If it is not given, if it is given, it's fine. If it is not given, you have to count like this. And then n, it is the total number of the random numbers. See, in each row 10 is there. So we have a 10 rows, means it is 100. So capital N is equals to 100. Now EI we can count, means we can find out easily because we know the value of capital N and the small n divided by n equal to 100 divided by 10. It is 10. Now you have to find out the length of each interval. In this question it is already given, it is equal intervals from 0.0 to 0.1, then 0.1 to 0.2 like that. But if it is not given, how you have to find out? Length of each interval is equals to 1 divided by small n. Here we know small n is 10, so this is 0.1. Equal interval length of each interval should be 0.1. That is 0 to 0.1, 0.1 to 0.2, like that it will vary. Now let me come for the table. See here, In the question they have given, you have 10 interval. So 1 to 10 and OI. This is the main thing in this problem. You have to see OI. What is this OI? It is the observed frequency. Here first what they have given, the first interval is from 0 to 0.1. From this table you have to just count the numbers which lies from 0 to 0.1. See here how many numbers are there from 0 to 0.1. You have to just count that. See, this is 1, 0.02, which lies from 0 to 0.0 to 0.1. Then 0.052, 3, 4, 5, 6, 7, 8. 0.10 also you have to consider, because 0 to 0.1, 8. We have 8. So first value I'll just write it as 8. Okay. Next, what is the next interval from 0.1 to 0.2? Some 0.1 to 0.2. Again you have to search for that number. 0.1 to 0.2. 1, 2, 3, 4, 5, 6, 7 and then 8. Okay, here see again it is 8. In the same way you have to calculate for third one 0.2 to 0.3, then 0.3 to 0.4, 0.4 to 0.5, 0.5 to 0.6, 0.6 to 0.7, 0.7 to 0.8, 0.8 to 0.9, 0.9 to 10. Like that you have to count. These are all the count you will get for OI. Then EI value already we have calculated, it is 10, capital N divided by N. Now OI minus EI, whether it may be negative value also, there is no problem. You have to calculate OI minus EI. Then OI minus EI whole square. Then our actual formula OI minus EI whole square divided by EI. We have to do the summation. So for each and everything you have to take the summation. That is 100, sum of this OI, sum of EI, sum of OI minus EI and sum of OI minus EI whole square divided by EI. Now let me come for the formula. In this formula we have x naught square, then summation OI minus EI whole square divided by EI is equals to 3.4. Now you have to find out x alpha to n minus 1. N is 10 you know, so 0.05, 9. I'll just show you the chi-square table. See here, this is the chi-square table. Here n is equals to 9. 9 we have here and 0.05 we have here. 9 to 0.05, that is 16.92. 16.92 is the value for x alpha comma n minus 1. So x square 0.05 is 16.92. Here what is the value of x naught square? 3.4. Now 3.4 is less than 16.92. So you have to accept the hypothesis and the numbers are uniformly distributed. This is your chi-square test. Here in this it is directly given, means the table is directly given, small n is directly given. If it is not given, I'll just show you one more example for that one. Yes. See here with this. Use chi-square test to check whether the given numbers are uniformly distributed in interval 0, 1 of equal length 0.25. They have given the length. The length of the interval is 0.25. They have not given the number of intervals. So what you have to do? You have to just go with n is equals to 20, because already this table is given. You have to count the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 14, 16, 18 and 20. So you know the capital N, that is number of random numbers. The length of each interval is given 0.25. With this, how to find out the number of intervals? Number of intervals is equals to 1 divided by length of each interval. That is 1 divided by 0.25. So your small n is equal to 4. Okay, and here they have given of equal length 0.25. So how you have to start with the table? You have to start with 0 to 2.5, then 2.5 to, see here, 0.0 to 0 to 0.25, 0.25 to 0.5, 0.5 to 0.75, 0.75 to 1.0. Like this, you have to have the interval and you have to count the numbers from the table and you have to do the problem. Okay. Thank you. This ends your uniform test. Next, we'll go for autocorrelation in the next session. Thank you.